All right, on the internet, there's a lot of people they are selling the concrete densifier. Now, concrete densifier is using the uh, lithium or sodium silicate or lithium silicate to react with the calcium hydroxide within the cement to form a densified surface. Now, for this to happen is that you need to have some kind of solution on top of it. And when I was searching for sodium silicate on internet, it often says that sodium silicate is used in cement, that you can use it for produce a waterproof cement, which will have a stronger density, although it will become white. But on YouTube, I cannot find any video about using sodium silicate. Most of the video online will be teaching using the commercial product, which is like a lithium one. Lithium one you can apply on a well-cured cement like this one. This is a cinder block. If you put lithium lithium silicate onto it, it will become crystallized in the surface. So these chemical will like sort of infiltrate inside and then react with the chemical reaction inside, and then it will form the crystallized surface. Not like this one, but here's one I'm gonna test out. Now, lithium silicate is quite expensive compared to sodium silicate. So I was wondering if I can use sodium silicate to produce a similar effect. Now this is a 500 millimeter of sodium silicate I bought from the chemical material store, which cost me about $3. And this is a pre-mix cement. Now I'm going to do one comparison. The first one is the regular cement, which is the pre-mix gravel without gravel, just cement pre-mix one with just water, and see what is like when I mix with sodium silicate inside this. Now on the internet, I learned that for sodium silicate, it can only use for fresh cement, which is that for any kind of cement like this one right here, you cannot use sodium silicate. Now I tried this before. It will only create a sort of white stuff on the surface. I believe is sodium silicate. They will react with a calcium hydroxide, which form a calcium silicate, which is a very good waterproofing and fireproofing material. Now, but this is on the cement, which is not very ideal. So I want to test it out if this one is used on fresh cement and how will it look like. Okay, well, when I was mixing the control set, this is the control set I mixed. It's still watery. Now, just a few seconds after I pour in the sodium silicate, I did not film that. It suddenly becomes super hard, and it just solidified now. What happened if I pour more water inside? And now it just become like water resistant, but I can still penetrate it. It's not super hard, but okay, I'll give you a good look on how the material actually look like. See, it become like a little bit water resistant. Seems like it's already cured for some time, but actually it's just within a few seconds after I pour in this one. So the effectiveness on sodium silicate on cement is quite amazing. Just a few seconds I poured in. So I'm thinking that this might not be good for, oh my god, the cement is already hardened. I cannot pour it inside the container. Maybe I'll try another batch. But it's already cured already, but just a few seconds. See? Oh my god. Now I have to try another way. Okay, so this is my second attempt for this one. Now this is just cement with water. Now last time I poured a lot of this sodium silicate inside, so it just cured like within 10 or 30 seconds. I think just 12 seconds or so. I just keep on stirring until one point I suddenly cannot stir anymore. Now I'm gonna try this one with a lower dosage of sodium silicate. Okay, give it a stir. So far so good. So seems like if I lower the amount of the sodium silicate concentration in the cement mixture, should be good. Now let's let it wait for it to cure and see how the result will be already. This is the one with sodium silicate. Just after some time, I can feel that the resistance on the box is larger than this one. This is the control set. The control set I can still pinch a little bit because it's still liquid inside. Or for the sodium silicate one, it can hardly move, and then I can feel some resistance inside the cement. I made another batch, which is using I put some dishwasher and then I shake it. After I shake it, it becomes like bubble-like. And this is, so it has a lot of bubble inside, and then it can cure very quickly. So in this way, you can use it to form some foamcrete very quickly. Now, because the bubble, if the bubble cracks, then the cement will collapse. Obviously, you will lose the bubble inside, and the foamcrete will lose its property of heat insulation and sound insulation. So you want the foamcrete to cure as fast as possible. And I think this sodium silicate would be a very wonderful solution for foamcrete to cure. Although you have to be very careful, because right now you can see this, it can hardly be scooped up right now. It will be very hard to process, and if operating on, if you carelessly put too much of this, it might cure inside your mixing tank, which might cause a huge problem. It's been more than 48 hours. Now this is the control set, and this is the one that I'm experimenting with sodium silicate. Now let's look at the control set first. The control set seems pretty normal, as what you could expect a normal cement, pre-mixed cement would be like. And this one is the one that mixed with sodium silicate. Weirdly, interesting enough, I think this part maybe is because the sodium silicate is curing too fast. So it created too much crack. Much like the failed experiment I had before, this one. This cured within 3 hours. And this is the result. And one more thing is that on the surface of the sodium silicate, as you can see, there is a thin layer of white or yellowish stuff that can peel off very easily. I'm assuming this is calcium silicate, which can be removed by hands very easily. And in terms of strength, I'm not gonna taste the strength right now, but for the cement one, the foam cement is really bad. Like, it cured too fast, and it's quite soft. And now let's take a look at the property of whether they absorb water or not. So this is the control set. Seems like the water will be soaked in, and this is the sodium silicate one. And it seems like water, they still cannot resist water. What about the surface on this side? Nope, still resist water. And yeah, I think that's pretty much it. So I'm guessing the sodium silicate is not meant it's not good for using on cement, because one, it's curing too fast, so it will definitely make the structural integrity much weaker. And the second one is it doesn't actually provide much water resistant effect that we are searching for. And overall, this might be, but if you're using sodium silicate to say like there's water leak or something that you want the cement to cure very fastly, sodium silicate might be a very good solution. But in terms of daily usage, I don't think you should put sodium silicate in your. So this is the control set. Since this is freshly cured cement, I put some of sodium silicate on the fresh cement. Keep in mind that this is the premixed cement doesn't have sodium silicate within the cement while it was curing, but I put on top of it after it was cured. So let's see how the results. It's been more than 2 weeks, and 2 weeks, almost 2 weeks after I applied the sodium silicate, and I haven't checked on these samples since, and to see how different they look from here. This one is the pre-mixture with sodium silicate with inside, and this one is the control set, which I only apply sodium silicate on top of it. And as you can see, the pre-mixture with sodium silicate on top of it is all crumbling now. Let's take a look at the water resistability. So as you can see that the control sample, even if they were this side, with applying the sodium silicate, it still absorbed water. So I would say that the whole sodium silicate will make the cement become water resistant and more harder. That was a failure example. But for this one, which still absorbed water, well, this is a quite interesting one, even though it's a quite failure. As you can see right here, the bottom of this is quite solid, while on the top of it is quite crumble and, I don't know how to say this, crispy. So my personal, this is just my, like I'm guessing and my speculation again on this one. So the sodium silicate, and they will react with the calcium calcium something inside the cement, and once it formed, it will form sodium calcium silicate. Calcium silicate is, they don't dissolve in water, so, and it's very light, so it will float on top of the cement. So what we can see right here, this is a higher concentration upper part. They have a higher concentration of the calcium silicate, while the lower part is just the natural cement that we have right now. So the lower part is quite rigid, just like usual cement. But since all the calcium silicate, they float onto the top, on top of it, the curing process is interfered by the calcium silicate, since it doesn't dissolve in water. And this is what happens when you have a bad curing cement. So that's the whole experiment. Thanks for watching.